Okay, today one of our goals is to see if we can count how many galaxies are actually out there in the Milky Way. We've been talking a lot about the structure of the universe. We kind of worked our way outwards from the Earth all the way out to the solar system, all the way out to distant solar systems, talked about our local group a little bit, the galaxy that we're in, the Milky Way, right? So the question that we have right now, that I have, is how many galaxies are there? Remember, our galaxy contains a lot of stars, and it is humongous. So just how many are there out there in the universe? And that's what we're going to try and discover today. So it says here in 1996, the Hubble Space Telescope wide field camera essentially left its shutter open for 10 consecutive days to take a picture of the edge of the universe. It's a famous picture. It's known as the Hubble Deep Field. Almost all of the objects you're going to see in the picture are actually galaxies that formed about 10 billion years ago, early on in our universe. The amazing thing about the picture is that the image only covers a tiny speck of the sky. Like, there's so many more galaxies out there than what you're going to see in this picture. And this picture is astounding how many there are. There's the old Hubble up there. Hopefully someday we'll replace that thing. It's been up there a long time. We've upgraded its mirror, all kinds of stuff. But it's still up there in space doing astronomy. So what we're going to do to start with is we're going to try to estimate how many galaxies there are in the actual Hubble Deep Field, the whole image, okay? So we're going to assume that every object that you see is a galaxy, and they really truly are, save for there's one or two actual stars in there, but everything in the picture is actually a galaxy. Maybe I can point some of those out to you. What you're going to do, each person individually, is going to mark out a square that's 3.7 by 3.7 centimeters somewhere in the Hubble Deep Field. Why 3.7? Because I had to make this fit with the size that the photocopier photocopies the picture on your paper. Okay, because I had to make it cover the whole image. So what I want you to do is count how many galaxies are in that portion of the picture. So here's what you're going to do. Here's the image, okay? And you'll notice, don't put your image over this. This is black. This is an area of the sky that it didn't get a picture of, okay? Anywhere in here, you can stick your image. So all you're going to do is you're going to take your ruler, find the metric side, pick a spot, literally any spot that you want to draw a square. You can draw it off the side if you want, make it easy. Doesn't really matter. Okay, and we're going to go, what did I say? 3.7, so 3.567. Okay, and then we're going to go down that many. If you're having trouble with the ruler, let me show you how that works. 3.5 is in the middle here. 6, 7 would be right on that line right there. Okay. Okay, so there's my other one. I'm going to draw this line out. This kind of lined up here. Okay. And now this should be 3.7 if we did the math right here with the ruler. Yep, we got it. Okay, so I now have myself a box. And all I'm going to do is count every speck I see in there. So look carefully. I mean, the tiniest little fleck of white that you see, you get to count. Those really little dots, they're like a pixel. Those things are actually galaxies. In fact, I have, in my picture right here, I do have one star. If you look close, can you see the one that looks a little different? This one right here, see how it actually has a star pattern to it? See that? This one down here is a star too. So it won't matter if you count that or not, but technically that's not a galaxy, that's an individual star that's in the Milky Way, so it's very close to us, and it looks like this. Okay? It's basically an effect of the camera's lens, why it does that. It's called a lens flare. But you're going to see, I think there's 1, 2, there might be a third one in this picture. I don't know. There's not many, though. I only see 2 off the first glance. But what you're going to do is take a minute now and count up every little white dot that you see in the picture that you marked off. All right, so here's a view of the actual Hubble Deep Field. This is the ultra-wide Deep Field, a new image that they have taken with an upgraded scope and for a longer period of time. So you can see the actual individual galaxies, like it's so beautiful, right? And if you look close, you'll see what I'm talking about with the star. Here's a star, here's a star, there's another one up there. Yep, oh, right there. Both of those guys are stars. That's a star. And you can see all the shapes of the different galaxies. Actually, in here there's a spiral like ours. A lot of spiral galaxies. So we've got, these are counts that the class just came up with. So what we need to do is we need to get an average for all of our counts. And those are some pretty typical numbers that, that we get. So let's go ahead and average this out here. If we take 63 plus 66 plus 70 plus 72, and then we divide by 4 numbers, we get 67.75. So let's say 68. We'll go ahead and round that. Okay. So this is the average that people counted in class. And even though we didn't have a lot of people counting, that's still pretty darn typical. Okay. Now this number represents 1/18 of the Hubble Deep Field image, which is why I gave you the 3.7 by 3.7. So that whole image, that square that you made is 1/8 of that, of the whole thing, okay? So we're gonna multiply by 18 to estimate how many galaxies are in that entire deep field. So 68 times 18 equals 1,224 galaxies. So we're saying there's 1,224 galaxies in this image. Just guessing, just off the top of your head here, do you think that's right? Do you think that's low? Do you think that's high? What do you think? It's probably a pretty low estimate, right? When you really get a look at that thing, it's probably pretty low. And if you could actually see, which you can't because this is a kind of a cruddy black and white picture, if you could look at it on the internet, you would actually see that the little things that kind of look like grains of, I don't know, it looks like kind of like the copier, just kind of was a little grainy. Every one of those little lightish colored things is actually a really, really itsy bitsy galaxy. So there's a whole lot more than that, but we're gonna estimate it based on what we've got here. So the Hubble Deep Field represents a small patch of sky. To understand just how small, if you put a dot, I mean the tiniest little dot, on a piece of paper and held it out all the way at arm's length from your body, the patch of sky that this entire picture covers is no bigger than that dot. Like, gasp. Think about how big the universe is. Holy moly. Like, that's just what we can see, right? It's not even the whole thing. So the Hubble Deep Field is about 0.017 degrees wide. A circle has 360 degrees, so let's calculate how many deep field images you could fit in just a circle all the way around you. So if we were gonna say this is an angular degree measurement, make a circle all the way around us, not a sphere, just a thin line all the way around us, how many deep field images would it have to stack side by side to go all the way around, to see all the way around every direction from the Earth? How would we do that? Anybody? There's 360 degrees in a circle. We're going to divide that by 0.017, right? Okay, type that in there, right? And you should, if you did that, if your calculator works like mine, you should get it. Okay, I'm gonna round it again. 21,000, a little over 21,000 just to go in a circle. But it's not a circle, right? Because we can see in a perfect sphere in every direction from the Earth. So you would need about 1,500 of those circles to construct a full sphere of the image. So how many to make this total sphere? Well, we need to then, of course, multiply, don't we? Times now we're getting up there, aren't we? That's how many images we need to cover the whole sky. That's a lot. Okay, well now, to estimate the number of galaxies in the universe, we're going to multiply this number by the galaxies that we estimated up here in step 3. So, by the number of Hubble deep field images, okay? We can just leave that right there like that. So we're going to multiply that times, where do we get our number of deep field images? How many deep field? There's our estimate. There we go. Oh boy. That's 10 to the 9 right there. Oh, we needed to, we did that, I did that wrong, sorry. Sorry, I was thinking something was wrong. We need to know how many were in, what we estimated here in step number 3, okay? By the total make a complete, so we need to multiply these two numbers together here. Let's back it up, something looked a little wrong. There we go. There we are, conveniently in scientific notation for us on my calculator. So we come out to like 3.9 times 10 to the 10. Everybody see that? 3.9 times 10 to the 10 galaxies. That's 10 zeros after that thing. Okay, so now, I'd like you guys to finish up with the rest of this reading right here. Read through this, it'll help explain it a little bit. And then there are just a couple questions on the back here. Okay. Your estimate of the number of galaxies in the observable universe, how does it compare to the accepted value, 1.7 times 10 to the 11? So compare our number here. Right? Look at that. It's considerably, I know that doesn't look like a lot less, but 10 to the 10 versus 10 to the 11 is a lot different. Like, that is a whole lot different, right? So that's orders of magnitude larger. So why was that so far off, do you think? We kind of mentioned it already. It has a lot to do with the fact that, like, your eye can't count properly on that picture because it's just a black and white image, right? You certainly can't see all of the, I knew you were going to come up short. That's how I could write that question. I knew there was no way you could actually count all the ones that were really in that picture, because you can't even see some of the tiniest ones are just a little smudge right there. You can't even see them, right? So there are a lot of galaxies, okay? And then there's a couple other questions here. Take a look at those, think about it just a little bit, and then you can work on your quiz for that one. All right, you guys want to talk about this one just a little bit? So, Carl Sagan, famous astronomer, right? We've watched some stuff from him already. So he's famous for pushing the idea that since there are so many galaxies, like an incomprehensible number of galaxies, like billions and billions of them, and each galaxy has billions and billions of stars. And if each star has, even just a couple of planets, or even just some of those just have planets, and even just some of those just have planets that happen to be in the right spot for liquid water, for life to exist, it seems almost unbelievable that the universe could exist and not have other planets with life on it, right? I mean, it just seems like almost impossible. So you can answer that however you like. The Hubble Deep Field Image lets you estimate the number of galaxies in a very small slice of the sky, right? Some of those are spiral, some are elliptical. You can see their shapes. Some are irregular. Galaxies have many different shapes. The ones in the picture, most of them formed over about 10 billion years ago. Okay? In comparison, the Milky Way is about 13.2 billion years old. So we're an old fart. Our galaxy's old. Some of the galaxies probably have stars with planets and moons. Some of these planets and moons might be in the right position to have the materials for life. What does the number of galaxies in the Hubble Deep Field Image tell you about the likelihood that there might be galaxies in the universe where we might find life? Right? Would the likelihood of a world capable of supporting life be greater in a galactic neighborhood that's older, like those in the Hubble Deep Field, or greater in a region of the universe that's relatively young? So that's an interesting question right there. And it kind of draws on lots of fields of science to try and answer this thing. Do we think that life would be likely to exist in regions of the universe that have galaxies that are really young as compared to really old? Well, what do you guys think? You think both? It's possible in both? Sure. A lot of scientists have kind of come to the conclusion that, well, we only have one example, which isn't much to go on, that life exists in our galaxy, which is quite old. But also, if you consider the fact that in order to have the complicated atoms available, like the elements available that you need for life, everything from carbon to, whatever else you might need, oxygen, hydrogen, nitrogen, like sulfur, all those important life-giving elements, you have to have enough stars create them. So in that sense, it might be more likely to find life in regions that are actually older than that are younger. But I agree, we have one example, and that's really not enough to go on, right? If we could find a few more examples, we might be able to make a better guess as to the answer to that. But that's one way of answering that question. So you should be able to do your quiz now.